Hello friends, let's begin with knowledge-based engineering. In this module, we will learn about knowledge-based engineering, how it's applicable, how the systems are developed in knowledge-based engineering, what is knowledge-based, and how the different things are there in knowledge-based engineering to generate a KBE model. Let's begin. KBS and knowledge. What is knowledge-based system? A system which is built around a knowledge base, that is, a collection of knowledge taken from a human and stored in a such a way that the system can reason with it. That is a knowledge base. Then what is a knowledge? Knowledge is a sort of information that people use to solve a problem. So knowledge includes facts, concepts, procedures, models, heuristics, examples. Knowledge may be specific or it can be general. It should be exact or sometimes it should be fuzzy. Procedural or declarative. So these are the different types of knowledge available in day-to-day life. Expert systems. What is an expert system? A particular kind of knowledge-based system, one in which a knowledge stored in a knowledge base has been taken from an expert in a some particular field. Therefore, an expert system can certain extent act as a substitute for expert from whom the knowledge was taken. Knowledge engineering. Knowledge engineering is often used to mean the process of designing, building, installing an expert system or other knowledge-based system. Some authors use the term mean just a knowledge acquisition. What is knowledge-based engineering? It is a engineering in a product development technology wherein the knowledge of engineered product and its design process is captured and embedded into the software system known as KBE system and the use of this system in design and development of the similar new product. It is a product-specific generic engineering knowledge that is captured and represented as a product model within KBE system, suite of KBE applications. These KBE applications are then used by designers to generate a new but similar product design for a new set of input specifications. In fact, this KBE application can be reused again and again to generate many new but similar product designs. Differentiating between knowledge and data. For example, the input of any product development comprises of specific values of product specifications such as size, performance, cost, appearance, etc. The output typically comprises of 3D part models, 3D assembly models, part drawing, assembly drawing, installation drawing, bill of material, etc. And these output depend on the values of input specification. As everybody knows that the input is shown in the example and output is different models. The knowledge component comprises of the rules, constraints, heuristics, guidelines, standards, design methodologies, etc. Those are broadly the knowledge can be classified into two types. One is explicit knowledge, another is tacit knowledge. So let's see the types of knowledge system, explicit and tacit. The explicit knowledge that is formalized and well documented knowledge like design manuals, engineering methods, material specification, engineering standards. So those knowledge is particular area and within the depth the knowledge is specified. For example, in manufacturing sector, whenever we design any component and if we forgot to give the tolerance, and that means that tolerance of the surface is not that much important. So we can move to the machining on normal lathe also. If we are mentioning some tolerance in 0.005, so that time we can into CNC machining. So such a depth of knowledge, such a different standards. In graphics also you will learn different types of standards. Those are in the engineering standards. For material also there are different types of specification, ISO, and different other specifications are also available. EN, light standards are there. Different engineering methodologies. That means uh, very basic idea for creating any geometry with different aspects. Those are very important: aesthetic, ergonomic, condition. Then design manuals. There are specific parts having design manuals. They are standard parts which are widely available in varieties of sizes and diameters and varieties of lengths and everything. Then tactic knowledge, which is embodied within the experienced engineers and not documented. That is rule of thumb, heuristic, observation, best practice, experiences, logic reasoning. So these tactic knowledge is coming from the experience. That means if in machining, if you observe that there is intricate areas where the our chips are continuously blocked the particular area, so that should be removed using some of the different burr system or sandpaper system. So that burr is easily removed and blockage is clear. So these are the rules or thumb rules we can show in the different observation point of view. If testing is failure, then how we can solve that problem of testing. Sometimes we change the any blockage wire, or sometimes the cables are changing, which require calibration purpose. So these are the observations and practices during the testing. And from the experiences only you will understand which are the input parameters are good for particular machining purpose or particular manufacturing purpose. So these are the tactic knowledge which are not documented. Knowledge and data components in product development. It's having a specific input data. So specific input data, as we have gone through previous slide, that data is nothing but all the sizes, performance, cost, constraints, design analysis, and manufacturing related. Those are only a specific input data. While basic generic generative product knowledge model is based on the methods, rules, heuristic constraints, guidelines related to aerodynamics, what is the space, how is the geometry complexity, then loads are there, where the loads are pointed out, and which weight is carrying out, where it is located, then design, how its design is working, and how we can remodify, redesign the tooling, which of the tools are required, which are available, which are required from the different countries for manufacturing and assembly the things. So these things are comes under the expert or which is in explicit knowledge, and it's integrate with the database. Material database is different, analysis database is different, engineering standard database is different, standard part catalog is different, regulatory codes are different, cost constraints are different. So as per the different integration with these data, we need to solve the knowledge with the model. That is, knowledge is a portion where applicable to product family and represented and held within KB. For example, if we go for aerodynamics, we check the material database, having different material database. For aerodynamics of a car, we are having analysis database, that is lift drag will be there. Then how the space and flow lines are there, those are major. Engineering standards we have to follow. Some rules we have to follow. Then standard parts catalogs are there. Then cost constraints are there. So these is a comprises a particular knowledge model within the system. Then we get a specific design output that is in FEM models, cost model, DMU model, 3D part assembly model, part drawing, etc. So data portion applicable for specific product of the family with given values of specification and represented and held within CAD, PLM and CAED. Now, generative knowledge within the KB system, how it works. So KB system having part of family. Like previously we gone through the different family of database. Okay. So P1 specification, product variant P1 of P. So P1 is a specification while P1 is a design output. Okay. So if it's having some of the input in the P1 and that will change the design output P1. So if there is a we are doing parameter optimization that time also if we change one of the particular size of any component that will easily affect the design of the component. Same like this. Then P2 specification is given to KBE family and P2 design output is checked. The product variant P2 of P. So this is the one of the generative knowledge within the KBE. Now, yeah, there are different organizations where KBE maturity level is defined using these three aspects. Of one is KBE driver, another is KBE penetration, and last one is KBE approach. If you go for KBE driver, so low maturity is based on tactical knowledge and individual driven. That is, it's just working on a task given to the worker. Okay. Medium maturity that is practical and locally driven. That is discipline level. So TV travel, that means some of the workers are supervisors. Those are easily disciplined the level or easily do the manufacturing or easily supervise the thing. While high maturity is strategic and centrally driven. That means strategic planning to reduce time from the science study and work study of the product life. So what will happen? We are reducing the time. That is strategic and centrally driven model. Okay, that is KB drive. Similarly, KB penetration. So it's having low maturity. Some of the part level, few disciplines are there, few applications are there. Those are easily understandable to the any new worker or any newly entered engineer. So the medium maturity that is component level, part level, many discipline, many application. That is multiple things are there in a one place. So that is we have to done in a supply chain management like this. High maturity will be product level, component level, and most of the discipline. So that is a managerial level. Then KBE approach, that is low maturity, that is unstructured approach and very less reuse. So structured is not properly planned and not properly group technology, not properly planned the fixed automation line or any another automation line. So that is a unstructured, that is low maturity. While medium maturity is semi-structured and limited reuse. That means we are reusing the things whichever available as per the time, and it is semi-structured most of the cases. And very structured and equitative reuse. That means the structured manner like our car assembly sections are there in Tata Motors and any other Mahindra and Suzuki, Maruti Suzuki. These are the very structured and equitative reuse because highly maturity level is they have attained to assembly the particular car within a few hours. So that is a very big maturity level that is arranged in KBA approach. So knowledge based engineering, this is taken from Tata Technology copyright. I have shown this diagram. It will give the on-site offshore interaction and more collaboration is required on the y-axis, while the x-axis is the task complexity. There is more knowledge transfer is required. Okay. So it's having methods of development. First is application testing, then macro development, scripting, user interface design and development. That is the first task. Second task is always the application development, application maintenance, methodology testing. Test case. Then third task will be database development, system integration, knowledge advisor, application optimization. While fourth will be application extension, database architecture, application migration, knowledge expert template. While fifth will be customization, integration testing, application of architecture to upgrade. And sixth will be OGT method of deployment, engineering tools, scan and benchmark. While seventh will be complex application development, business knowledge template, product knowledge template, rule-based. And eighth will be advanced methodologies, design engineer optimizer, intellectual property protection consulting. Then nine will be channel development, multi-CAD, multi-domain integration engineering. So this having a very difficult task as per the task is 136. Those are easy tasks. When we move to the next part, the tasks are more complicated and more number of things are required. Some of the times the manager having a very good thing and it will have to continuously integrate with the system and it will reduce that particular part and reduce the time and more knowledge transfer is done. While offshore interactions are those are that is more collaborative interaction. So 135 or 136 is more collaborative information that is from different departments. While on present tax complexity is in different departments, but it is in increasing manner. So KB application development approach by Tata technology, if you observe, first is there is a discover that is gather information on product or process to identify solution elements to vigilance of existing application architecture. Then we have to define, that is retrieve the information, outline migration methodologies, specify and refine requirements and solutions, and then develop. So that in definition there is a detail and refining is continuously taken place, while in development improve and validation part will be taken place iteratively or continuously, and that feedback is going to the defined requirement. That is, in development is test and document the methodologies, encode the applications and test models, and then prepare the training materials for upcoming engineers. Then that could be iterative process in deployment. It is always given to the discover, define, sometimes. So deployment is nothing but install and verify, deliver the trainings and provide on-site. For example, if we move for CV development approach, we will observe due diligence, requirement gathering, planning, unit testing, application development, software system design, integration and regression testing, verification and validation, and review. With the help of due diligence, existing applications, understanding, tracking, mitigation, and define coding standards. Required gathering means review and review the requirements and provide the. Then planning, that define functional requirements, define technical specifications, define test plan, define acceptance criteria checklist. Then software system design, develop class diagram, then list out system dependencies, then traceable and complex matrix. Then application development, where the development application framework based on design. Then SPM, source code maintained in SPM. Then error and expectation handling. In unit testing, the test against unit test plan, generate test report, and cross-verify and traceability matrix to ensure all requirements. In integration and regression testing, that is having old and new frameworks we have to tally. Then performance testing, execute the automated test, record new test cases, review a checklist, verification and validation, that is identification of sample example uses pilot release, then deploy the pilot machines and perform user tests, address any user issues, review and update checklist, release that is code version SPM, prepare software documentation, training document, and prepare user document. So if we go to the NX application development area, how it is actually developed from modeling to different area. Modeling comes under geometric handling, dimension, layer management, expression, view, then solid body handling, and exit entry. While drafting, that is view management, inserting charts, adding new tabular nodes, and changing at runtime. So UI styler is having bottom top dialog, callback mechanism, construct dialog at a runtime, styling dialog, then parametric modeling having UDF installation, formula, then bash programming that is external application batch program, overnight automation task that is programming of particular software, then multi-CAD integration, communicating between the other CAD and the application with different programming languages. Thank you so much. Hope you understand very well.